Before we get started, a huge thanks to our sponsor, Mitsubishi Electric. Mitsubishi provides all your heating, cooling, and filtration needs in one system. Today's low-load homes require right-sized equipment that most systems, especially gas-fired, cannot meet. Mitsubishi has low-load, high-efficient heat pumps that dehumidify and cool in the summer and work in reverse to heat in the winter. Going ductless reduces costs and make it even easier to meet many of the Energy Star requirements. Ductless mini splits can now be hidden in many different ways to meet your client's needs, and ducted systems can now be used as well. Ducted systems are also hidden behind the walls to ensure beautiful space and can be retrofitted right in place of a conventional furnace in an existing single-family or multi-family project. Hyperheat ensures an efficient heat delivery down to -13 degrees, and backup strip heaters kick in during the rare but coldest of cold days. Just launched today, the first set of hyperheating inverter products to be released in 2020. The introduction of these new outdoor units creates an additional 25 systems capable of hyperheating performance when it's really cold out. So check out that. We'll be spreading more information there. And the way it works is each room of a house can be customized, and so can multi-family buildings and commercial buildings with variable refrigerant heating systems with energy recovery built right in. You can heat on one side, cool on the other, just as needed. Go to MitsubishiComfort.com to learn more. And thanks to our second tier sponsors, Rheem, featuring the Rheem Prestige, an energy efficient, quiet, and all-electric hybrid heat pump water heater. The future of water heating is finally here. 50, 65, or 80 gallons, all the way up to 3.7 uniform energy factor. In other words, almost over 300% efficiency for these units. With different ducting and ductless systems, depending on your strategies and climate zones, as well as leak detection. Learn more at rheem.com/hybrid savings.
Okay, phase two. So phase two is really where we get into this kind of advanced design and we kind of refine the energy model. We perform a cost-benefit analysis. A basis of design is developed, as well as this preliminary documents that involve any kind of submetering setups. So this is phase two is usually achieved through the design development of a project, the DD phase of a project, leading into this 100% construction drawing set. So it's probably one of the longest phases of the program. But it also is kind of requiring like the most amount of effort in terms of the energy modeling, as well as this feasible cost, this cost benefit analysis. This is also the phase of when this preliminary measure list becomes much more refined by the design team as a result of energy modeling and a result of this cost benefit analysis. What's required in terms of the energy model? We are requiring a building simulation to predict this annual energy use of the proposed design and the savings associated compared to the baseline design. We also require the savings to be separated out per energy conservation measure. We, in terms of what is required to be submitted for the program, energy model output reports, as well as executable files from our approved software. The approved software is in line with most kind of building simulation approved software lists that you'll see, definitely in line with LEED's requirements there. And basically the software tool needs to be able to model 8760 hourly data with variation dependent on schedules and weather. This kind of deliverable must ensure kind of this proposed model or this predicted kind of model will meet this EUI goal that has been identified in the earlier phases. The primary responsibility for this deliverable would be the energy modeler, supported by the design team and the owner. Now, this cost-benefit analysis phase, this is also extremely important and kind of piggybacks onto this energy modeling. We want to have this cost-benefit exercise where you can establish kind of what measures are going to work for you in the design in terms of a simple payback, return on investment, or internal rate of return. We require these calculations to be submitted. They can be in any kind of form that you see fit. We don't require a certain cost-benefit analysis software at all. a spreadsheet showing this analysis will suffice. We also require, as a result of this cost-benefit analysis, an updated list of approved ECMs. Now, the basis of design document, this is a document that is built from the OPR that was submitted in phase 1. Essentially, this document is kind of owned by the design team, whereas the OPR document is more of an owner's, is coming from the owner. This basis of design is usually separated out into the disciplines. You'd have a mechanical basis of design, electrical, plumbing, etc. So it's very typical to what you would see for a design construction project. However, we ask that the ZNE EUI goal is listed in this document, as well as a detailed description for each of the ECMs for the final design. And again, that can be separated out into those disciplines, whatever is appropriate. But what we're asking is that this EUI commitment that is made and kind of documented from the OPR is kind of carried through into this basis of design document. And just a note about the submission requirements there. It is submitted kind of for initial review prior to your 50% construction drawings to ensure there is kind of enough time to implement those changes. So we do have a requirement that it is submitted before 100% CDs in the schedule. The last kind of deliverable in phase 2 is the submetering and construction documents. And basically, we're requiring here that the project is set up for kind of end use or tenant level submetering, and that the phase 3 and phase 4, which involve commissioning and measurement verification, as well as performance testing, can occur. And that in the design drawings, there is actually this submetering kind of circuit plan that allows for this ongoing measurement of your end uses to actually occur once the building's occupied. So we require a submetering plan and a list or a table of these end uses or tenant spaces to be monitored per circuit. Electrical drawings usually will have this plan and will show kind of the connections to designated areas. And we also require that this is provided in the 100% construction drawings. Primary responsibility for this would be your electrical and HVAC engineers, and second responsibility kind of supported by the design team and the owner. Again, we want to make sure that for the preceding phases where commissioning and measurement verification is kind of an essential deliverable, we just want this your project to be set up for success for these phases, and we require kind of the submetering outline to be present in those design drawings as well as construction drawings. So as I mentioned earlier, this program requires projects to be solar ready. And so we do like to see that the structural design loads are clearly indicated for a future solar system. We like to see on the drawings that there is kind of a plan for connecting that PV system to the electrical system of the building. There is no requirement to install a conduit, but rather we want it kind of to be indicated on the drawings where it would be installed for the future, for the system at a future date.
Thanks for watching. Please continue to watch the next part of the session to complete the course and get your continuing education credits. Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.